In this video, we are going to be talking about the differentiation from first principle, which is a differentiation as an increment notation of a function. Let us assume that we have two functions, which is given in terms of x and y. And when we're talking about increment, we are talking about a very small increase. We call it infinitesimal increase in these two functions, which is x and y. So if we have if you have a function that is given in terms of x and y, the increment of x is going to be in form of delta x, and this will bring about a corresponding what increment of y, which is given as delta y. Now, how do we solve question which is differentiation according using the first principle? Let us take for an example. We have our y to be equals to x squared. Now, this particular method of differentiation requires steps. It requires following a particular step, which I'll be mentioning now. Now, the first step is to take the increments of both x and y, which means take the increment of the both sides. Remember that the increment of x is delta x and the increment of y is delta y. And if we want to say that something increase, we are going to say that if our x is, let me say for example, if our x is 5 meter, for example, I'm just saying an example, and the increment is 0.1. To know the value of x now, what you're going to do is what? We are going to have 5 meter to 0.1 meter, which is going to give us 5.1. Which means to know the increment now, we are going to say that x plus delta x. Also, the same thing for y plus delta y. Therefore, we are going to take the increment of the both sides to be y plus delta y equals to, now, our x half squared, which means we are going to be having x plus delta x squared. We have that. That's the first thing we are going to do. The next thing we are going to do is to open this particular bracket. In opening this bracket, what we're going to have is what? We're going to be having our y plus delta y to be equals to x plus delta x into bracket x plus delta x, which will correspondingly give us what? X times x is going to give us x squared plus delta x times delta x is going to give us x delta x. Also, x times delta x is going to give us x delta x. And if we add the both of them together, we're going to be having what? We're going to be having 2x delta x, right? So that is x squared plus 2x delta x plus delta x times delta x is going to give us what? Is going to give us delta x squared, y plus delta y. Now the next step is to make delta y the subset of the formula. We want to make delta y the subset of the formula. Therefore, our y, or our delta y rather, our delta y is going to be, we are going to take this y, put it at the back, right? We're going to be having x squared plus 2x delta x plus delta x squared minus y. But we remember that our y equals to x squared, right? And therefore, wherever we see our y, we are going to put x squared. Therefore, our delta y equals to x squared plus 2x delta x plus delta x squared minus what? Minus x squared. Now, we have a positive x squared here. We have a negative x squared here, which means positive x squared is going to cancel out negative x squared. And we are going to be left with what? We are going to be left with delta y equals to 2x delta x plus delta x squared. The next thing we are going to do is that divide the both side, or let us say we are going to look for the gradient of the both side. You understand? Which means we are going to divide the both side by delta x. Divide the both side by delta x. Now, divide this one by delta x. Divide this one by delta x. We are going to be having delta y upon delta x equals to, if you look at this very well, we have delta x here. We also have delta x here, which means we can factorize outside. In factorizing outside, we are going to be having what? We are going to be having delta x into bracket 2x plus delta x divided by delta x. So delta x is going to cancel out delta x. We are going to be left with what? We are going to be left with delta y divided by delta x, 2x plus delta x. The next thing is take the limit of delta x to be equals to 0, which means we are going to take the limit of delta x to tends to 0, delta y plus delta x equals to 2x plus delta x. Now, in this case, this is a Leibniz notation. This particular one is going to turn to a Leibniz notation, where if we take the limit of delta x to be equals to 0, this delta y upon delta x will become what? Will become dy upon dx. You understand? And remember that delta x equals to 0. So wherever we see delta x, we are going to put 0. Therefore, delta x upon delta y or delta y upon delta x is going to become what? Is going to become dy upon dx, which is equals to 2x plus 0. And 2x plus 0 equals to what? Equals to 2x, which means our answer, dy upon dx equals 2x. Equals to 2x. So this is basically how to differentiate using first principle. And when we say that dy upon dx, it means that we are differentiating y with respect to x. That is basically what we mean. You understand? So the greatest of function y f of x is f prime x. You understand? And f prime x equals to dy upon dx. So in some cases, you can see them writing it as what? You can see them writing it as dy upon dx. You can see them writing it as f prime what? F prime x. You understand? So these are the things that we have here. You understand? So these are the gradient of the function. I get it now. Remember I told you that the y upon the x is, you have to note that the y upon the x is the limiting value of delta y upon delta x at delta x tends to 0. That should be noted. You understand? So let us take for an example. By taking an increment of delta x in x and delta y in y, let us find the following. Let us find the 1 minus 3x plus 2x squared. Let us take this. Now, this is very easy. What we're just going to do is that first, take the increment of the both side. That will be y plus delta y equals 1 minus 3x plus delta x plus 2 into bracket x plus delta x squared, right? We have this. The next thing is that we are going to open this particular bracket using this squared, right? So we're going to be having y plus delta y equals to 1 minus 3 into bracket x plus delta x plus 2 into bracket. Remember how we did it the other time? We are going to be having x plus 2x x plus x squared. Right? Now, the next thing is that what? The next thing is, let us open all of these brackets. You understand? Multiplying 3 with x, multiplying 3 with x, multiplying 2 with x, and so on and so forth. So we're going to be having y plus delta y equals to 1 minus 3 times x is going to give us 3x plus 3 times x is going to give us 3 x plus 2 times x is going to give us 2x plus 2 times x is going to give us 2, which is 4x x plus 2 x squared. Right? We have this already. You know the reason why this one is 4 is because 2 multiplied by 2, that is 4x x. You understand? Now the next thing is that I'm going to make y the subject of the formula by subtracting the both side by y, right? So I'm going to have what? I'm going to be having y, which is delta y, equals to delta y. I'm coming. delta y equals to 1 minus 3x dot x, 1 minus 3x dot x, sorry, 1 minus 3x plus 3 dot x plus 3 dot x, right? Plus 2x plus 4x dot x plus 2 dot x squared, then minus y. But we know that our y equals to 1 minus 3x plus 2x squared, right? We know our y is that, which means instead of writing minus y, we are just going to write what? We are going to write minus. So I'm going to clean this now. We are going to write minus into brackets 1 minus 3x plus 2x squared, right? Plus 2x squared. Now, I think the mistake that we made here, they're supposed to be squared here. They're supposed to be squared here, right? So they're supposed to be squared here as well, 2x squared, because x times x equals to x squared and stuff like that. Now, the next thing is, if we open this bracket with this particular negative number, we are going to be having negative of all of this, right? Which means this one is going to become what? Instead of 1, is going to be minus 1. If you open with minus negative number, it's going to be minus 1. This one is going to be plus 3, and this one is going to be minus 2x squared. So it's going to become minus 2x squared because we are multiplying everything with minus. You understand? So which means we have a positive 1 and a negative 1. They will cancel out each other. You understand? We have a positive 3x and a negative 3x. They are going to cancel out each other. We have a positive 2x squared and a negative 2x squared. They are going to cancel out each other, which means our dy, which is delta y, is now going to be equals to 3 delta x plus 4x delta x plus 2 delta x squared, right? Sign is always a problem around this place. It's supposed to be, yeah. So the next thing is that what? We are going to divide the both side by what? We are going to divide the both side by delta x, divide the both side by delta x, right? So if we factorize delta x outside of this place, we are going to be having delta y upon delta x to be equals to what? To be equals to, factorize out delta x, we are going to be having 3 plus 4x plus 2 delta x, everything divided by delta x. Delta x will cancel out delta x. We are going to be taking limit of the both side by 0. So limit of delta x to be equals to 0 of delta y upon delta x to be equals to what? To be equals to 3 plus 4x plus 2 delta x. And that's going to give us what? Anywhere we see delta x, we put 0. But the limiting value of delta y upon delta x at delta x tends to 0 equals to what? Equals to dy upon dx. Equals to 3 plus 4x plus 2 multiplied by 0. And that will be equals to what? That will be equals to 3 plus 4x plus 0, which is equals to 3 plus 4x. So this is how to differentiate using first principle. You understand? So this is how to differentiate basically using the first principle method. Let's take for an example. We are given a question like differentiate y equals to exponential 2x using first principle. Using first principle method. What we're just going to do is that what? We're just going to say that y, taking the small increment of the both side, y plus delta y will be equals to exponential 2x plus delta x. You understand? Now, the next thing is that I'm going to open this particular bracket with 2. And I'm going to be having y plus delta y equals to exponential 2x plus 2 delta x. But remember that from our law of indices, a raised to power m multiplied by a raised to power n equals to a raised to power m plus n, which means basically I can rewrite this one as what? I can write it as y plus delta y equals to exponential 2x multiplied by exponential 2 x. You understand? Because m plus n equals to a raised to power m multiplied by a raised to power n. You understand? That is just the law of indices. It's just the what? Law of indices. Now, the next thing is that I'm going to make the y disolvable formula, take this one back, and I'm going to be having what? I'm going to be having our dy to be equals to exponential 2x multiplied by exponential 2 x minus y. What is our y? Our y is exponential 2x, which means exponential 2x. We have this already. The next thing that we can do is that we can actually factorize outside. You understand? We can factorize things out. In factorizing something out, we can factorize out exponential 2x. You understand? Exponential 2x. And in factorizing that one out, we are going to be having dy to be equals to exponential 2x into brackets exponential 2 x minus 1. We have this. Now, if you multiply this one with this one, we are going to be having this one. And if you multiply this one with this one, you are going to be having this one. That is what we have. Now, we are going to be using something we refer to as power series, or some people call it Taylor's and Maclaurin series. Power series, basically. You see, in power series, exponential 2x, like ordinary, like something like exponential 2x, for example, it is going to become 1 plus x plus x squared. Sorry, it's not supposed to be exponential x, rather exponential x, rather exponential x. It's going to be 1 plus x is power 2 divided by 2 factorial plus x is power 3 divided by 3 factorial dot 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 till infinity. You understand? It's just like saying x is power 0 plus x is power 1 plus x is power 2 divided by 2 factorial plus x is power 3 divided by 3 factorial. Still the same thing. But we know that x is power 0 equals to 1. So that is 1 plus. That's how power series work. Which means our exponential 2 x is now going to be what? Exponential x equals to 1 plus x is power 1, right? Which is this x that is here. Which means our exponential 2 x is now going to be what? Is now going to be 1 plus, are you getting me now? 1 plus 2 x plus, just like x that is here, plus x squared. So it's going to be 2 x squared over 2 factorial plus, it is x power 3. So it's going to be 2 x cubed over 3 factorial dot 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 till it reaches infinity. It goes like that, you understand? Therefore, if we want to write this, whenever we see this exponential 2 x, we are going to be putting all of this, you understand? So it's going to be what? It's going to be our dy to be equals to, what do we have here? We have exponential 2x, right? So that is exponential 2x into bracket 1 minus 2 x, sorry, 1 plus rather, 1 plus 2 x plus 2 x squared, or let me say that 4 x squared, because 2 raised power 2 equals to what? Equals to 4, you understand? So that is 4 x squared upon 2 factorial plus 8 x cubed upon 3 factorial, right? 3 factorial dot 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 till infinity minus 1 because of minus 1 that is here. You understand? Now, we have a positive 1 here and we have a negative 1, which means positive 1 cancel out negative 1. What's the next thing we are going to do? Divide the both side by what? Di x. So our dy upon dy x is now going to be equals to exponential 2x. Are you getting me? Into brackets 2 x plus 4 x squared upon 2 factorial plus 8 x cubed upon 3 factorial dot 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 everything divided by what? Everything divided by delta x. So we can factorize delta x outside. This delta x, we can factorize outside. I'm going to be having what? We're going to be having the y upon the x to be equals to exponential 2x, then delta x, let me use a square bracket, then delta x into bracket 2 plus 4 delta x divided by 2 factorial plus 8 delta x squared divided by 3 factorial till infinity. You understand? Everything divided by what? Everything divided by delta x. So I factorize the delta x outside. So we have delta x here, we have delta x here, we have delta x here. I just factorize outside and I'm going to be having this. So delta x cancel out delta x. The next thing is to take the limit of delta x to be equals to 0 of delta y upon delta x to be exponential 2x into bracket 2 plus 2 into 4 is going to be 2 x 2 delta x plus 8 delta x squared. You understand? So whenever we see delta x, we are going to put 0. This one become dy dx. Dy upon dx equals to exponential 2x into bracket 2 plus 0 plus 0. Because 2 multiplied by 0 equals to 0, 8 multiplied by 0 equals to 0. And that will give us what? That will give us our dy upon dx to be equals to 2 exponential 2x. That's our answer for this particular one, because 2 multiplied by exponential, because 2 plus 0 plus 0 will give us 2. 2 multiplied by exponential will give us 2 exponential 2x. So this is how to differentiate using first principle method. Although there are different methods for differentiation, we have the general rule of differentiation, we have the function of a function, which is chain rule, we have what else do we have? Function of a function, we have implicit function, we have product rule, we have quotient rule, we have partial derivative, we have differentiation of multivariate function, and so on and so forth. We are going to be discussing all of them in this particular channel. Don't forget to subscribe to this channel and follow for more. Thank you.